Hello everyone. In this video, I am explaining block diagram of 8259 PIC, that is programmable interrupt controller. So as it is written, it is a programmable device. That means we can program it and it is interrupt controller. So let's start with interrupt. So what is interrupt? Now we have already studied 8085 and 8086 microprocessor. Now we know that in 8086 there are two interrupt pins, that is NMI and INTR. These are hardware interrupt pins, and let's assume that there are two devices connected, that is device 1 and device 2. This is main program of processor, that is it is a group of instructions which is stored in memory. And this is program of device 2. This is also stored in the same memory but at different memory location. That means this main program and this interrupt routine, both programs are stored in the same memory but at different locations. Now this device 2 wants to execute this program. Now assume a situation in which any of this processor is executing a program. Presently it has executed instruction 1, instruction 2 and instruction 3, and instruction 4 is in progress. And device 2 want to execute its own program, that is consist of group of 5 instructions. But this is device, it is not a processor, and hence it is not capable to execute these instructions or not capable to execute this program. So in this situation, what this device will do, this device will take a help from this processor. So what this device will do, it will send interrupt request on INTR pin to this processor. So it will transfer logic 1 on INTR pin to any of this processor. When processor receives logic 1 on this pin, it understands that now some device want my help for execution of program. So what processor does, suppose it was executing currently this instruction 4. So first it will complete the execution of instruction 4 and it will send acknowledgement on INTA bar pin. This is interrupt acknowledgement bar pin. This is bar. Bar indicates it is active low. So it will transfer logic 0 on this pin to device 2, indicating that I am ready to execute your program. And then after sending acknowledgement, this processor will transfer its control to memory location where this program is stored, and then this processor will start fetching instruction from this separate memory location and will start execution of this program. After complete execution of this program, again microprocessor will go back to its original program, its own program, and it will start executing instruction 5, 6 and 7 and so on in sequence and finish its main program. So whatever request this device sent to the microprocessor on INTR pin is known as interrupt request. Why it is interrupt request? Because it is interrupting this microprocessor during execution of its own program. It is interrupt, it is disturbance, and hence it is interrupt request. The program, the main program of 8086 is known as main program, and the program that device want to get it executed by this device, by this processor, is known as interrupt routine. And this program is known as interrupt service routine. Now 8259 is defined as programmable interrupt controller PIC, and this is a block diagram of 8259. You can see on left hand side that there is data bus buffer, read write logic, cascade buffer. On right hand side there are four registers: interrupt service register, priority resolver, interrupt request register and interrupt mask register. We are going to study every block of this 8259 in detail in coming slides. Always remember that this is an interfacing IC. On this side, we always connect processor. On right hand side, we connect devices. Now, if you see this side, you will see here interrupt request register and there are pins. So these pins are from IR0 to IR7, that is known as interrupt request 0 to interrupt request 7. So here you can connect the interrupting devices on this pin. Now, as we studied in this diagram, you can see that these devices can be directly connected to the processor for interrupt requests. Then what is the role of 8259? What is the use of this 8259 programmable interrupt controller? So let's see. Suppose this is a processor, this is 8259 connected, and here we can connect different devices. So what we are doing actually in this, we know that in 8085 microprocessor there are 5 interrupt lines. So there we can connect 5 interrupting devices. And in 8086 there are 2 interrupt lines, that is NMI and INTR. So here we can connect 2 interrupting devices. But if there is a situation in which we want to connect multiple devices, interrupting devices to 8086, say 15 devices, 30 devices, 50 devices to 8086, then in that case it becomes very, very difficult. And hence, in that case, we need a help of 8259, that is programmable interrupt controller, to increase the interrupting capability of 8086. So what this 8259 is doing, actually we can connect this 8259 to INTR pin of 8886, and we can connect 8 different devices to this 8259. So earlier capacity, if you see only INTR, we can connect here only one interrupting device. But if we connect 8259 to this INTR pin, then we can connect 8 devices to this processor. So this is how this 8259 increase the interrupting capacity of processors. You can see here this device 1 is connected to IR0, then device 2 is connected to IR1, and so on. And there are devices, and device 7 is connected to IR6, and device 8 is connected to IR7. That is interrupt request. So if device 1 wants to send interrupt request to 8086, so first device 1 send request to 8259, then 8259 will send that request to processor, and then processor will acknowledge to 8259, and then 8259 will acknowledge to device. Now let's see each block diagram of 8259 in detail. So let's start with this data bus buffer. This is data bus buffer. So it is a 3-state bidirectional 8-bit buffer. So it is 8-bit buffer, that means, and it is bidirectional. That means data can flow in both directions. That means 8086 can transfer a data to 8259 or can receive a data from 8259. When 8086 transfers a data, it is said that it is a write operation, and when 8086 receives a data from this 8259, it is said that it is read operation or receive operation. Now, since this D0 to D7 8-bit data bus is connected to data bus buffer, only 8 bits can be transferred and received at a time. Now let's take an example. Suppose 8086 wants to write a control word to this 8259. What is control word? Whenever we want to initialize 8259, whenever we want to use 8259, we have to write control word in the control word register in the control logic of 8259. Suppose that control word is 3E, and 8086 want to write that control word to control logic, then this data or this word will always flow through this data bus, through data bus buffer to internal data buffer, and so on. So data flows through data bus buffer. This is a write operation. That means 86 wants to write a control word in the control word register. Suppose 886 wants to perform read operation. Read operation means, suppose there are 3 registers in interrupt service register, priority resolver, and interrupt request register. Suppose 886 wants to read the status of this register. Status means what is stored in interrupt service register. Suppose there is 11110000, and 886 want to receive this data or read this data or read the status of this register, then that data will also flow through data bus buffer. So data bus buffer is for data transmission and for receiving a data from 8259. Now next block is read write logic. Read write logic is responsible for read and write operation. There is one pin, that is A0 pin. A0 is input signal which is in conjunction with write bar and read bar signal to write command into various command registers. This is A0 pin of 8259 which is used along with this read bar and write bar pin only. Alone it is of no use. It is of no use. Now remember that read bar of 886 is connected to read bar of 8259 and write bar of 886 is connected to write bar of 8259. And this A0 works along with read bar and write bar for read and write operations. Now here it is shown that this complete A0 to A19 is connected to A0, but it is not like that. Any of the address bus of 8086 can be connected to A0 address pin of 8259. Now what is read write logic? This block works only when value of CS is 0. So you can see here there is one pin, that is CS bar pin in 8259, which is active low, and it is known as chip select bar. This is used to select this particular 8259. Means this particular 8259. If we want to select this 8259, then this chip select bar should be 0. So 886 or any decoding logic should transfer logic 0 on this pin to read write logic so that it selects this 8259. It is used to switch on the 8259 in short. Now, as I said, when 886 wants to transfer a data, it is said that it is a write operation. When 886 wants to write a control word in the control word register, it is a write operation, and hence you can see here it will transfer logic 0 on the write bar pin. And after sending this, it will transfer this control word through data bus buffer to control word register. Now, if 8086 want to read the status, then it will transfer logic 0 on read bar pin. You can see here read bar logic 0. If 886 want to receive the status or read the status of any of these registers, say now this interrupt request register, 886 want to read what is stored in this register, then first it will transfer logic 0 on the read bar pin, and then this will flow through data bus buffer. So remember, write operation is transfer operation and read operation is receive operation. Remember that both cannot be 0 at a time. Either write will be 0 or read will be 0. Now next block is control logic. Now whenever we want to use 8259, we have to initialize it, and for initialization we have to write proper control word in the control word register. Now, as the name suggests, it is a control logic. That means this block controls the overall functioning of this 8259 or all the operations of 8259. It has one output pin and one input pin. It has output pin, that is INT, which is connected to INTR of 8086. That means interrupt pin of 8086. You can also connect this INT to NMI pin. And interrupt acknowledgement of 886 is connected to INTA bar pin of 8259, which is connected to the control logic. Suppose this device 1 wants any operation, or device 1 wants to execute some program, interrupt service routine. So first device 1 send a request to this interrupt request register. Then after that, this 8259 will transfer that request by sending logic 1 on interrupt pin to 886. And then 886 gives an acknowledgement by transferring logic 0 on INTA bar pin. You can see here like this, by transferring logic 0 on INTA bar pin to 8259. So control logic is it is for control operations. Now next block is interrupt mask register. So here you can see this is interrupt mask register. Interrupt mask register is nothing but it is simply 8-bit register. As name suggests, it is a 8-bit register. Every bit is responsible for one input pin. That means this bit position represents this IR0, this IR1 bit position, this represents this IR1 request on this pin, and so on. As name suggests, it is a mask register. Masking means avoiding. Suppose this 8259 wants to avoid the interrupt request on particular pin coming on particular pin, it can be done through interrupt mask register. Now you can see here IR2, IR3, IR4, 6 and 7 are 000. 000 means they are unmasked. Unmasked means if some device send a request through, suppose device 8 send interrupt request on IR7 pin, then it is available. It is not masked and this 8259 will receive this interrupt request. Or suppose device 7 transfers the interrupt request on IR6 pin, then this is also 0. So this 8259 will receive that request. But IR0, suppose IR0 is 1. In this register, interrupt mask register, if this bit position is set to 1, and if device 1 send interrupt request on IR0, then this 8259 will reject this request. It will reject this request sent by device 1. Now, if IR1 is also 1 and device 2 is connected to IR1, and if device 2 sends a request by sending logic 1 on this pin, since in mask register it is already masked, then the request coming on this pin will be rejected. So this is a use of interrupt mask register. Interrupt mask register is just to avoid the unwanted interrupt request. Now here IR5 is also 1. So if some device sends request on IR5, that will also be avoided. Now next block is interrupt request register. So if you see this block diagram of 8259, you can see here. This is block diagram of 8259. These devices are connected to IR0, IR1 and IR7, and this block is interrupt request register. So this is interrupt request register. Again, this is 8-bit register, and for every bit position represents the interrupt on particular pin. So this is for IR0, IR1, IR2 and so on, and this is for IR7. Now what this interrupt request register does, it stores all interrupt level which are requesting for interrupt service. Means whatever device send the interrupt request, the interrupt request register will set that bit. So suppose device 1 sends logic 1. Again see, if device 1 sent logic 1 as a interrupt request on IR0 pin, because device 1 is connected to IR0, then IR0 bit will set to 1. If device 2 send request on IR1 pin, then IR1 will be 1. And if device 8 sends request on IR7, then that will be 1. And if other devices do not send any interrupt request, then all these bits will be 0. So what it does, this interrupt request register just stores the interrupt request coming on that particular interrupt pin. Now next is priority resolver. What this priority resolver does, priority resolver will check the interrupt request register, which interrupt is there, then interrupt mask register and interrupt service register. And based on it, it will decide the priority which interrupt request should be serviced first. What interrupt request register does, whatever interrupt it receives, it will set. Now what, suppose there are interrupts on two devices, that is device 1 and device 8. You can see device 1 is connected to IR0 and device 8 is connected to IR7. Now you can see that both are sending interrupts at a time simultaneously. It is not one by one, at a time. So what interrupt request register will do? Interrupt request register will set this bit 1 and this bit 1. And it will forward, this interrupt request register will forward this information to priority resolver. Then priority resolver will decide which should be forwarded to processor. That means whether this device 1's request or device 8's request. That means IR0 should be serviced first or IR7 should be serviced first. So priority resolver decides the priority. If IR0 has the higher priority than device 8, if device 8 has lower priority or IR7 has lower priority, then it will priority resolver will transfer that particular bit to interrupt service register, and interrupt service register is also 8-bit register. It also has 8-bit positions for every interrupt request pin, and it will set this bit to 1, and then the same interrupt will be sent to microprocessor for execution of interrupt service routine. That means what priority resolver is doing? Priority resolver is checking what is there in the interrupt request register. This bit is 1 and this bit is 1. Then it will check interrupt mask register. It will check whether this is masked or not. Okay, if both are not masked, if both are available, then it will check whether this is having higher priority or this has higher priority. And if it finds that IR0 has higher priority, then it will transfer IR0 information to interrupt service register, and interrupt service register will set it to 1, and then it will send that interrupt to microprocessor. So this is the job of priority resolver and interrupt service register. So what interrupt service register hold? It stores the interrupt level which are currently being executed. That means this, because this is transferred to a microprocessor for execution. So this is currently being executed. So because processor will execute it. So that information is available in interrupt service register. Now next is cascade buffer. Now what is the use of cascade buffer? Now let's assume that earlier we had only two interrupt pins on 8086 INTR and NMI on which we can connect two devices. So to increase the interrupting capacity of 8086, we connected 8259 to 8086, and thereby we could connect 8 different devices to IR0 to IR7 pin of 8259. But now suppose that is also not sufficient and we further want to increase the interrupting capability, then what we can do, we can connect 8259 to 8259. That means to IR0 pin, this is also 8259. You can see this is 8259. So IR0 pin of 8259 is connected to 8259 1. Then IR1 is connected to another 8259 and so on. And then IR7 is connected to 82598. That means we have connected 8 8259 to these 8 interrupt request lines, that is IR0 to IR7, and every 8259 again have 8 interrupt request pins, that is from IR0 to IR7, and here we can connect actual interrupting devices like this. So there are 8 8259 connected to this pin, and every 8259 we can connect 8 interrupting devices, and hence we can connect 64 total interrupting devices to processor if we connect multiple 8259 to this one 8259. And this is said that it is in master slave configuration. So this 8259 is master and this is in slave configuration. So when we connect this 8259, this is suppose master and this is slaves, all these are slaves. So when we cascade this 8259 in master slave configuration, then every slave has its identity number. Suppose this 8259 is, this is first which is connected to IR0, its identity number should be 000. The second 8259 will be 001 and so on, and this 8259 will have identity number 111. Now you can see here there is a cascade buffer, and in this cascade buffer there are three lines, that is CAS0, CAS1 and CAS2. So at a time, even if we connect multiple devices and multiple 8259 to this processor through this one master 8259, 8086 can communicate to only one device at a time. Let's assume that this 8086 is connected to this 8259 and this device connected to IR0. So since this is first 8259 and its identity number is 000, that time This will hold 0, 0, 0. So this CAS0 to CAS2 holds the slave identity number, and this is a function of cascade buffer. So what is written to increase the interrupt handling capability. So this is how we can, and here also you can show that to NMI also you can connect 18259, and again to this 8259 you can connect another 8 multiple 8259. So to increase the interrupt handling capability, we can further cascade more number of pins by using cascade buffer. So during increment of interrupt capability, CSA lines, these CSA lines are used to control multiple interrupt structure. So what these pins hold? So they hold the slave identity number. So this was all about 8259. What is the purpose of this programmable interrupt controller, why we use it, and what is the function of each block when we use 8259 to the processor. Maybe it is 8085 or 8086. So 8259 is slightly critical to understand, but I tried to make it as easy as possible. I hope you understood the concept. But if you still have any query or doubt, you can always ask in the comment section. Thank you very much. Thanks for watching.